In this video tutorial, we are going to use the JavaScript mapping library to build the coverage map that you see on your screen. This is a terrain map, which in a city renders the streets, buildings, parks. We have added several layers on top of this map, the semi-transparent polygons that you see. They represent delivery area covered by couriers of a transportation company. We can turn on and off each of the layers. The last layer renders pins on the locations where the company has offices. We start by creating a new file in Visual Studio Code. This will be the web page for the application. We call it coverage. Let's add now the mapping and other UI libraries used by the page. We've downloaded a copy of MindFusion JavaScript pack and extracted it on the hard drive. There we have the scripts folder with the JS files for all libraries included in the pack. However, we will get the scripts from the scripts folder that is inside the mapping subfolder of the JPack. We copy the scripts and themes folders and go to the directory of our HTML file. There we create a new folder and move the web page there. We also copy there the scripts and themes folders. The scripts folder contains TypeScript files as well. Though we will not use them directly, we will reference them in code because they provide IntelliSense support in VS Code. There we also have Themes folder, which contains all themes available for the mapping control. The themes are CSS files, which you can edit directly or copy to create your own themes. Let's add now the body tag to our web page. At the end of the page, we add references to those of the JavaScript files in the scripts folder that are required by the mapping library. We also need to reference a new JavaScript file, which we call coverage. This is our code behind file and will contain the logic of our application. We add now title to our web page and add reference to the standard theme. The name of the CSS file determines the name of the theme. The theme classes inside also have the theme name as prefix. Now we create a div element that spans almost on the whole page. In it, we place another div, which has an ID. It is important because this div will represent our map, and we need the ID to refer to it when we create the map view instance in a minute. With that, we are ready with the web page and we can start coding our mapping application. The first thing we do in the JavaScript file is add a reference to the two TypeScript files that declare the classes, which we will use. Thus, we can have IntelliSense support in the code. Then we declare two namespace mappings. We create then the map view using reference to the div element which we've declared in the web page. We need the HTML element that represents it, and we get it with the getElementById method. The theme is standard, which is the name of the CSS file that describes it. We go on creating a new map layer. This is one of the types of layers supported by the library. The map layer requires the address of a tile map service that will provide the images, e.g., the titles for the map. There are various free and paid TMS services. We use the free service of Stamen Maps, which is based on OpenStreetMaps. We use the terrain map. The map layer class has a property attribution where you can place the link to the free service if you are required to link to it. Most likely you will be. Finally, we add the layer to the layers collection of the map view. Let's check one of the online samples for the mapping library. It is called Coordinates and shows the geographical coordinates of a point that the user has right-clicked with the mouse. We use this sample to get the coordinate in the center of the area where we are currently located. Then we call the load method of map view where we provide the location and the zoom factor as parameters. The location is an instance of the lat_long class, which represents geographical locations to be used by the library members. Now, if we load our web page in a browser, we should be able to see our map. And here it is. We will use the sample to get the coordinates of the edges of a polygon that will represent our first area. We create an array that will hold 4 lat_long objects that represent those coordinates. Of course, when you develop your mapping application, the coordinates of points to appear on the map will most likely be provided to you. We create now a new canvas layer that uses the points array. The string in the constructor represents the name of the layer and it will appear in the map legend. Next, we initialize a poly that is a polygon figure with edges as specified by the points array. The stroke and fill properties specify the colors of the polygon. Note that the fill is in RGBA format because we want it semi-transparent. The stroke thickness is not in points or pixels, but meters. Yes, when the zoom of the map changes, the stroke will change as well. The dash style is solid. The polygon is not smooth, e.g., it does not have rounded edges. It is closed, which means the first and last point are connected. Finally, we add the poly to the decorations list of this canvas layer. We create now 3 more arrays with points that we get from the coordinates sample. Those are the edges of the other polygons. We create 3 more canvas layer instances and 3 more polygons. The code is absolutely the same as the code for the first layer and the first poly. The difference is in the colors and the layer names. Let's refresh the page to see what we've done. Here are the layers and each one has its name. We can turn them on or off. You can hide the Map Layers widget if you want. The last layer is the layer with the offices. We add a new array with their coordinates and create a new layer. This layer is a decoration layer. Its name is Offices. We need to create the pins that will mark the office locations in code. They are instances of the marker class. We create a marker for each point in the office's points array. Note that we add the points to the decorations property of the layer. One more thing to note. You need to call the load method of map_view at the end of your initialization code. Now we see our map in its final look. All layers are in place and all markers as well. The pins layer is not visible by default. We can zoom the map, show and hide the layers and decorations. We are ready, and this is the end of this tutorial. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.